Right. Okay, we are recording, so now we can get to business. We got a couple of questions to go over. I don't know if they come from this class or not. I don't think they do. So I'll go over them for both classes. The first one is 8.1, 19/5. 19/5. And this looks like a question we've done either I've done it in the other class or this class. They kind of run together, so I can't remember. I think this is the chapter 7 and 8 question, where A is chapter 7 and B is chapter 8, I believe. So I'll let y'all write that down. I'm going to pull up my handy dandy document cam and make it small, so get it out of the way. There we go. And y'all can be writing some of that down. And yes, this is a test question because this is the kind of question I would put on the test for 8.1. I'm not going to put a crazy, tricky question. I'm not going to do that. So the question says, and I better get my, oh Lord, what do I do with my pictures? Oh shoot. I got some, there they are. Let me get this stuff out of the way. Okay, so take our handy dandy picture of our bell curve, and it says a mean of 134. A mean of 134 and a standard deviation of 13. So that's going to be 147. And 13 would be what? 160 and 173. Somebody check my math, please. 134 minus, oh gosh, 121 maybe. Somebody's going to have to check me on the subtraction because I suck at subtraction. 121 minus 13 is going to be what? 109 or 108? 108. Thank you. And 108 minus 13 is what? 95?
Yeah.
Thank you. Let me guess, that was Miss Cameron. I appreciate you, Miss Cameron, interacting with me. Thank you. One day you'll have a nice office.
Thank you.
Yeah, you will. Because everybody else winged on a pickle, they'll have a closet office down at the end of the hall, beside the ladies' men's restroom, because they don't communicate. All right, and it says the probability that a randomly selected pregnancy lasts less than 130 days. So 130, I'm going to take my handy dandy ruler. Let's see, 134, we said that the standard deviation was 13. Half of 13 is 6.5. So that's going to be 140.5 right there. And they want to know 130. So this would be 6.5, be 127.5 right there. So that'd be 127.5. And that, I said that would be 140.5. I'm trying to just see where 130 would be. So that's 127. Half of 6.5 would be 3.25. So that would be 130.75 right here. So I'm going to do that as 130. And they want to know less than. So I'm going to take my handy dandy highlighter and I'm going to highlight this area. Right here. I think I did pretty good. I usually don't color inside the lines very well. That's pretty good. So my number right here is 130. So if you've got a new calculator, you could actually do this one now without any problem because you could type in everything and get your answer. But I'm going to go ahead and change at 130 just in case we have somebody with an older calculator. That'll be 130 minus 134 divided by 13. And since I've only got one or two people in here that knows how to communicate, I'll go ahead and pull up my calculator and do it. Y'all know in relationships, whether it be a career or personal, you know, you have to communicate. If you don't communicate, it pretty much ends up bad. Just thought y'all would like to know that. And again, nothing. It's all right. You'll remember it one day. 130 minus 134 divided by 13. I got negative 0.31. So our z-score for 130 is negative 0.31. Now you only need that if you have an older calculator. Now remember, we got negative infinity down here. That arrowhead is called negative infinity, which we can't use infinity in our calculations. So we use negative 9999. So I'm going to hit second, VARS, normal CDF. And if you have an older calculator, because it's defaulted at 0 and 1, so we're going to say this is an older calculator, and then we'll do a new to check. Negative 9999, negative 999999. Put as many as you want to, it doesn't matter. Upper is negative 0.31. And this is an older calculator, so I can't change 0 and 1. So our pink area is 0.3783. Let me get my pink highlighter. Hold on. Where is my pink? There it is. So my older calculator says 0.3783. 37.83%. And our, let me get these moved around for you. Oh, the things I do for y'all. So unappreciative. And to move that over. You're welcome. Okay, now we'll do a new calculator. Second, VARS, normal CDF, negative 9999 to 130, 134 and 13. Now, granted, the newer calculator will probably be a little bit more detailed because it carries everything to 10 digits internally. So if there's a decimal or anything where we might change it to 2, it will take it to 8. So between the older and the newer calculator will be more detailed. Enter. And this one is 3792. 3792. So the newer calculator is 0.3792. Now, actually, we could probably get it a little bit closer with the older calculator, and I'll show you how you could do that. Second, let's go with, let's recalculate that. 130 minus 134 divided by 13. And instead of writing this down, and instead of rounding it, I'm going to stow it. You know, that's where you get bread. It's stow. I'm going to stow it. And I'm going to call it, since it's a z-score, we got a z in here. There's a z above the 2. I'm going to say alpha z, which is 2. And I'm going to store it. Okay, because previously I changed that to 0.31, which causes a z-score. But I'm going to leave it at that, and let's see how much it changes the answer. So second vars, normal CDF, negative 9999 to alpha z, 0 and 1, and paste. Now, with the older calculator and us rounding off, we got 0.3783. With not rounding off, we get 0.3792. So it does make a difference if you keep it in there. So I would probably, if you have an older calculator, I would probably stow it or just write out the 10 digits and type it back in. So with not rounding, the old calculator, not rounding, we got 0.3792. Okay, so that's a chapter 7 problem. Okay, that's not anything different that we did. I'm sorry, chapter 8. Now it says, okay, of course that would be, we would expect 38. That's 38%. So 100 people or 100 pregnancies, that would be 38, would be less than, would be expected to be less than 130 days. You never use the word exactly in probability, and this says more than. So those are not the answers because of those two, more than and exactly. Suppose a random sample of 17 pregnancies. Okay, now we've got something different. So I'm going to do this in green. Now we've got 17 pregnancies. Or say you get a random sample of 17 pregnancies. Now that could be in addition to what we do. That's usually what it means. And it says describe the sampling, blah, 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 blah. So we need to get a new standard deviation with this new information. So we need to get a new standard deviation for this new info. So we know that the mean is 134. It's still the mean of X bar is equal to 134. And the new standard deviation of X bar is going to be equal to n, which is 17, over the square root of 13. So that's going to be our new standard deviation. So take out our handy dandy calculator. And let's do 17 divided by, and I'm going to do this in parentheses, excuse me, gone, 13 raised to the 0.5 power, close parentheses. Oops, sorry about that. Okay, that's 17 divided by the square root of 13. And that is my new z-score. I'm sorry, not my new z-score, my new standard deviation, 4.7. And that is my new standard deviation. So 4.7. And for easy purposes, I'm going to say 5 so I can do it on the, sorry, I'm going to say 5 so I can put it on here a little bit easier. So 134 is the middle. This will be 139. This will be 144. And this would be 149. 5 from the 134 is 129. 5 from 129 is 124. And 119. Now, what does the question ask? The question says now, wait a minute. Oh gosh, did I say 17? What did I do in my calculation? I bet I did, and y'all didn't say nothing, of course. Yeah, I did. Why didn't I get the same answer they got? 17 divided by the square root of 13. I don't know if that's the right answer or not. Can somebody check? Did y'all get 4.7? Hello?
Yeah.
Okay, I got one person. Did anybody else get it? Anyone else besides Miss Cameron used their calculator and got 4.7? I just need somebody to say yes or no. Oh my God. What am I supposed to do, Miss Cameron? I mean, what am I supposed to do? I mean,
I don't know.
then people complain about the class. Well, these people make the class. These people that don't talk, they make the class. So it's not my fault they're winged on a pickle. All right, so I don't know why I can't get this. I don't know if that's the answer or not. I can't click on it. I don't know. I really don't know, so I'm just going to keep on going. All right, it says, what is the probability 130 or less? 130 or less. Well, 129 is right here. And the difference between 129 and 134 is, of course, 5. Half of 5 is 2.5. So 2.5 added to that is 130. 2.5, 131.5 is right there. So this is 131.5 right there. And 130, I guess, 2.5 is 1.25. 130 would be right here. So 130 is this green line right here. That's 130 by the new information. Okay, so the green, and usually your chapter 8 area is going to be less than your chapter 7 area. It's usually going to be less. And this is why. Okay, so I'm going to find, so if I want to find this z-score right here for 130, I'm going to do 130 minus 134, not divided by the last standard deviation, but now divided by 4.71 or whatever we get there. 4.71 ... So we know that 130 minus 134 is -4. So take our handy dandy calculator and we're going to do -4 divided by second answer, and that'll bring in that 4.7 blah blah blah. So our z-score is -0.85, -0.8584 ... I'm going to stow that in alpha z. So I'm going to stow that, stow alpha z. And now I'm going to do inverse norm. I mean, not inverse norm, normal CDF, -9999 to -0.84. And then I'm going to do -9999 to 130 and do it in the new and the old calculator. So second vars, normal CDF. And this is the old calculator set up, so I'll just do -9999 to Z and hit paste. And I get the green area is 0.198117. 0.198117. ... Now let's do it the new way. Second vars, normal CDF, and that's going to be 130 with a mean of 134 and a standard deviation of, oh gosh, I forgot what it was, 4.71. Can y'all give me a few more digits? What was it? I'll just ask McCameron because none of y'all will answer me.
4.7149.
49. Okay. And paste. And 0.19811. See, it's a little bit off because I didn't have all the digits. So 0.198111. So 0.19811, and I think that's 4, be 5. 4 ... So that's for the green area. And that's chapter 7 is in pink. And chapter 8 is in green. So let's see what they got, because I don't know how they got the right answer. That 3.15, I don't know if that's correct or not. And they got 0.1, They got the correct answer, so I don't know how they got 3.15. I don't know how they got that. I don't know if I'm reading something wrong. 134, 13, should be 13 over. Oh, I think I know what I did wrong. And y'all should have called it. I did it bass backwards, didn't I? No. Yeah, I did. I did it bass backwards. Y'all didn't even catch it. Don't say I thought. No, you should have said something. Back here is supposed to be n. No, it's supposed to be the standard deviation over the square root of n. That's why I got the wrong answer. It's supposed to be, I can't think. The standard deviation is 13. It's supposed to be 13 over the square root of 17. I transposed my numbers. And not a single one of y'all said a word. Appreciate it. Thanks for the help. And I can 13 divided by, divided by square, let's see, 17 raised. Sometimes I can't work a calculator. I'm sorry. So the 0.5 power, and then close parentheses. There we go. My bad. So I'm going to stow that. I'm going to stow it in alpha S for standard deviation. So stow alpha S for standard deviation. Okay, and that would make things totally different. Well, anyway, I'm going to punch in the new. So that's going to be 130. So that's going to be -4 divided by the alpha S. And that's going to give me -1.26. And that's going to be your new z-score, -1.26. So second var is 1.2686. 1.2686. -1.2686. And 1 and 0. And this gives us a better. And it, whatever. It didn't like something. .2686. I don't know what I'm typing in wrong. Let me do it with, I've typed it in the way I always type it in. Normal CDF, 1.2686, and paste. I have no idea. Let's type it in, vars, normal CDF, and 130, and mean is equal to 130, 130, 4. And standard deviation is alpha S and paste. 0.10228. Let's check and see if that's better. 0.10228, which is 1223. So I feel better now that I did that. Sorry I messed that up. And I appreciate y'all mentioning. Thank y'all. And I want to go back and try that again. Second bars, normal CDF, negative 9999. And my upper would be negative, what do we say it was? 1 point what? What did somebody write it down? 1 point what? Oh, well, just forget it, man. We just won't do it. We'll just go on to the next question. Y'all don't really care, so. Next homework question for those that actually give a rat's rear end. 8.2, 7/4. Describe the sampling distribution. Assume the size of the population is 10,000. Okay, they want you to test this. As I told you in the 8.2 presentation, you've got to make sure that NPQ is greater than or equal or is less than or equal to 10. NPQ is less than or equal to 10. And you got to make sure that N is less than or equal to 0.05 of big N. Oh, and when we do have class, when we do in class today, I would appreciate it if you don't, get out of, I know you don't like the class, but when you leave the class, as soon as I say the class is over, that usually tells the instructor that you hate the class with a passion. So be a little bit more professional. I'd appreciate it. All right, NPQ is 200. Well, N is 200. P is 0.4. Therefore, Q is 0.6. Well, I'm just going to use a little bit of common sense. 0.4 and 0.6 is around 0.5. So half of 200 is 100. Half of 100 is what? What's half of 100, people?
50.
Thank you, Miss Cameron, of course. Okay, that's a problem. Unless I've done something wrong. That is, wait a minute, did I copy? I bet I copied it down wrong. Let's see. It's got to be greater than 10. I switched it around, I'm sorry. So, and that's greater, is 50 greater than 10? Yes. All right. And big N is 10,000. So little n is 200. Is 200 less than 5% of 10,000? Well, 10% of 10,000 is 1,000. And 5% would be half of 10,000, which is 500. So this one does check because 50 is greater than 10 and 200 is less than 500. So let's go with approximately normal because little n is less than 500 and NPQ is greater than 10. So it should be B. Determine the mean of the sample distribution of p hat. And remember how we get the mean. I'm just going to pull it up because I'm not going to go searching for it. The mean of the sampling is the same. So the mean, where's the mean here? Well, they don't give us the mean. Oh, it's the same as should be 0.4. Sorry, hold on. 0.4, same as P. And there's our new standard deviation is going to be the new standard deviation is going to be the square root of, I always get it transposed, I'm sorry, n, or the standard deviation over the square root. And if we don't have that, we're going to use the formula. I'm going to bring the formula up so I don't have to rewrite it. Square root of NP, square root of P hat Q hat over N. The square root of P hat Q hat over N. Okay, I just wanted to bring that up so you wouldn't know I was making it up. So here our standard deviation is equal to the square root of P hat times Q hat, P hat times Q hat over N. And that's going to be equal to square root of 0.4 times 0.6 over 200. And that's going to be 0.4 times 0.6, 0.4 times 0.6. Oh, well, we're still in freaking whatever mode. There we go. 0.4 times 0.6 divided by 200. And raise that to the 0.5 power. Our standard deviation is 0.0346. 0.0346. 0.0346. And that should be your answer. Let me look back and see what I did wrong. 0.0346. Unless they got 0.0, I'll try 0.0347. $0.0345. Oh, it says round to 3 decimal places. I'm sorry. I didn't read the directions. Okay, has anybody got any questions? No, because nobody's going to say anything. So, all right, well, y'all have a good weekend, and I'll see y'all Monday.
I do have a question about the data project.
What is that?
It asks for the type of distribution and to test for normality. Is that just like for the type of distribution? Is that like skewed?
Yeah, they're asking if it's normal, skewed left, or skewed right. So when you do your total when you do your total and get your mean and standard deviation, or when you just do yeah, they're asking you for if it's a normal distribution or if it's skewed left or skewed right. I'm not really concerned with it. I'm just making sure as long as you get the standard deviation and mean and draw a good diagram and all that good stuff and have everything presented, that's all I'm gonna grade you on. Remember, this
Okay.
isn't mine. This ain't even the math departments. This is from somewhere beyond the math department. So
Right.
just turn in something real nice.
Okay.
Okay. Any other questions? Okay, well, I'm gonna do like some of y'all. I'm just gonna end class and get out of here like a bat out of Hades. Y'all have a good weekend.
You too.